Here is a sequence of shapes made from squares and circles. The sequence continues in the same way. The formula for the number of circles, c, in relation to the shape number, n, is c equals 3n minus 1. Use the formula to work out the shape number which has 104 circles. So it's important to understand that 3n means 3 times n. Now we know that c, the number of circles, is 104. So 104 equals 3n, 3 times the shape number, minus 1. So before we subtracted 1 from 3 times the shape number, that would have been 105, because 105 minus 1 is 104, so 3n must be 105. And if 3 times n is 105, to find n, to find the shape number, we can divide 105 by 3, and 105 divided by 3 is 35. So that's shape number 35. 35 times 3 is 105, minus 1 is 104, and that's the number of circles. Now write the formula for the number of squares in shape number. So we have the number of squares here and the shape number n at the top. So the number of squares is going from 3 to 5 to 7 to 9. So we can spot that it's increasing by 2 each time. Now what we can do, because it's increasing by 2 each time, is to write the 2 times table. So write 2, 4, 6, 8. Then we can see that the number that we have, the number of squares, is always 1 larger than the number in the 2 times table. So because it's going up in 2's, we have 2n, 2 times n. But then because the number is always 1 larger, we need to write plus 1. So our formula, s equals 2n plus 1. And we can check that it works, because if n is 1, 2 times 1 plus 1 is 3. If n is 2, 2 times 2 plus 1 is 5. 2 times 3 plus 1 is 7. And 2 times 4 plus 1 is 9. So 2n plus 1 is our formula. Carol went on a 40-kilometre cycle ride. This is a graph of how far she had gone at different times. How many minutes did Carol take to travel the last 10 kilometres of the ride? So we know that it was a 40-kilometre ride. So after 40 kilometres, Carol had been riding for 120 minutes. But we want to know how long it took her to ride the last 10 kilometres. So that will be from 30 kilometres to 40 kilometres. So if we draw a line across from 30 kilometres, we can see that she reached 30 kilometres at 80 minutes. So if we find the difference between 120 and 80, that's 40 minutes. So it took her 40 minutes to ride the last 10 kilometres of her journey. Now use the graph to estimate the distance travelled in the first 20 minutes of the ride. So we can draw a line up from 20 minutes, and then where that hits the line of our line graph, we can draw a line across. So we can see that it's going up in 5s with each square, because we have 0, 5, 10, 15 and so on, and it's between 10 kilometres and 15 kilometres. So I would estimate 12 kilometres. You also get the mark for an estimate of 13 kilometres. Now Carol says, I travelled further in the first hour than in the second hour. Explain how the graph shows this. Well, 1 hour is 60 minutes. So if we draw a line up from 60 minutes, we can see that we have about 22 kilometers here, because remember the next line will be 25 and it's roughly in the middle. So it shows 22 kilometers travelled in the first 60 minutes, but it's a 40-kilometer ride altogether. And if 22 kilometers were travelled in the first hour, this means that 40 minus 22, so 18 kilometers, was travelled in the second hour, and 22 kilometers is further than 18 kilometers. Children were asked to choose between a safari park and a zoo for the school trip. They had a vote. The result was a ratio of 10-3 in favour of going to a safari park. 130 children voted in favour of going to a safari park. How many children voted in favour of going to the zoo? So we know that it was 10-3 in favour of going to the safari park. So what this means is that for every 10 children who voted for the safari park, 3 children voted for the zoo. Now we know that 130 children altogether voted for the safari park. So we need to think 10 times what is 130. Well, 10 times 13 is 130. So if we do the same for the ratio that chose the zoo, 3 times 13 is 39. So that means that 39 children voted in favour of going to the zoo. The diagram shows a right-angled triangle and 3 parallel lines. Calculate the size of angle X and angle Y. So we need to find angle X and angle Y. But with geometry problems involving angles, what's the best approach is to just put as much information as we can work out onto the diagram. So we can see that this is a straight line, and we know that angles on a straight line have to add up to 180 degrees. So this angle here must be 35 degrees, because 180 minus 145 is 35. Now we have a square in the corner here, so we know that that's a right angle, so 90 degrees. And then we have a triangle here, and angles in a triangle add up to 180 degrees. So 90 plus 35 is 125, and if we subtract that from 180, we get 55. So now here we can see that we can find angle X because we have a Z or backwards Z angle. And we know that we can use backwards Z angles because we have parallel lines. These little arrows show that the lines are parallel, and the question even tells us that the lines are parallel. So if this angle here is 55, the angle opposite will be 55 as well. So X is 55 degrees. Now here we have 55 degrees, and again because we have parallel lines and a line intersecting them, we know that the total of these two angles will be 55 as well. So if this part is 35, then Y will have to be 20 to make 55 altogether, because we have a line crossing parallel lines. We could also find out a lot more or solve these in different ways. So here we can see if this angle is 55, then these two angles together will have to total 55 as well, because again we have a Z angle. Or if we have a straight line here, we have 180 minus 55, so this angle here is 125. Then, because we have straight lines crossing, opposite angles will be the same size. So this will be 125, and this angle here will be 55. We have a triangle here, so because we know two of the angles in our triangle, we can work out the third by adding up what we have and subtracting from 180. So 125 plus 35 is 160, and if we subtract that from 180, we get 20 as the other angle in our triangle. Also, spot that we have another Z angle here. So if we know that this angle is 20 degrees, we know that angle Y will be 20 degrees as well. We can also check that the angles inside this larger triangle add up to 180. So we have 90, 35, and then 35 and 20, so that's 55 degrees altogether. And 90 plus 35 plus 55 gives a total of 180. We can also work out this angle here, because we have angles around a point. So we have a point here, and then whichever direction we move in, we get to an angle. So we can work out 20 plus 35 plus 145, and then subtract from 360, because angles around a point always total 360 degrees. That gives us 160 degrees for this angle here. And we can find this angle because we have a straight line. So 55 plus 90 is 145, and if we subtract that from 180, we get 35. Or we can find this angle here. 20 plus 35 is 55, and if we subtract that from 180, we get 125. We can also spot that because this angle here is 125, this angle must be 125 as well, because they're opposite sides of a Z angle. The numbers in this sequence increase by equal amounts each time. Write in the missing numbers. So we have 2.5, then a missing number, then 13.5. So to get from 2.5 to 13.5, we have two jumps, and that's a difference of 11, because 13.5 minus 2.5 is 11. So if we want to find the difference for one jump, we need to find half of 11, or divide 11 by 2. We can write that as the improper fraction 11 over 2. And then if we change that into a mixed number, we keep the denominator the same, and 11 divided by 2 is 5 remainder 1. So the difference with each jump is 5.5. So to find this missing number here, we need to work out 2.5 plus 5.5. That's 8, because 2 plus 5 is 7, and then half plus a half makes an extra 1, so that gives us 8. Now for this box, we need 13.5 plus 5.5, because remember, the difference is the same, it's 5.5 each time. So that's 19, 13 plus 5 is 18, half plus a half gives us 1 extra. So now, for this final box, we have 24.5 plus 5.5, so that's 30. 24 plus 5 is 29, a half plus a half is 1, so that's 30 altogether. 2x plus y equals 20. So 2 times x plus y equals 20, and we need to know the value of y when x equals 6. So we need to work out 2 times 6 plus what equals 20. Well, 2 times 6 is 12, and then 12 plus 8 is 20, because 20 minus 12 is 8. So when x is 6, y is 8. Now we need to know the value of x when y equals 2. So 2 times x plus 2 equals 20. Before we added 2, we would have had 18 here. So we need to think 2 times what is 18? Well, 2 times 9 is 18 plus 2 is 20. So that means when y is 2, x has to be 9. 96 pupils and teachers go by minibus to the sports tournament. How many 15-seater minibuses will be required? So here we need to divide 96 by 15 because we know that there are 15 seats on each minibus but 96 seats needed altogether. So the way to divide 96 by 15 is to count up in steps of 15 until we get past 96. So 15 is 1 times 15. If we add another 15 to 15, that gives us 30 for 2 times. Adding another 15, we have 45 for 3 times, 60 for 4 times 15, 75 for 5 times, 90 for 6 times, but that's still not enough because they need to take 96 pupils and teachers, and 6 minibuses would only be enough for 90. So we need to add another 15, and that way we know that 7 minibuses can contain 105 people. So because 90 isn't enough, that's too few, we need 7 minibuses altogether to take all 96 of the pupils and teachers. In a class, the ratio of boys to girls is 7 to 4. There are 9 more boys than girls. How many children are in the class? So a ratio of 7 to 4 means that for every 7 boys in the class, there are 4 girls. So we can draw a bar model with 7 bars for boys and then 4 bars for girls. Now we know that there are 9 more boys than girls. So we know that 3 bars must have a total of 9. Because that way, if we ignored these 3 bars, there would be 4 bars for boys and 4 bars for girls. But these 3 bars here tell us how many more boys there are. So if we know that 3 bars represents 9 children, that means to find 1 bar, we can divide 9 by 3, and that means that each bar represents 3 children. Now we have 11 bars altogether, so we have 3 times 11, so that's 33 children in the class. There are 7 times 3, so 21 boys, and 4 times 3, so 12 girls. Write in figures the number 3 million. So figures means the same as digits, and 3 million is a 3 followed by 6 zeros, because the 7th digit from the right is our millions digit. Then we have our 100,000s, 10,000s and thousands digits, then our hundreds, tens and ones. Write a fraction which is greater than 0.7 and less than 0.71. So when we have decimals, we can write zeros on the end without changing the value of the number. And that will help us think of a decimal that's in between these numbers, which we can then turn into a fraction. So 0.7 is the same as 0.700, because all these zeros tell us is that we don't have any hundredths or any thousandths, we only have 7/10ths, so that tells us the same as 0.7 does. And for 0.71, we can write a 0 on the end, so that's 0.710. And now that we have zeros on the end, and we have numbers which now have the same number of decimal places, they both have 3 digits after the decimal point, we can easily think of a decimal that will be in between these numbers. So we could have 0.701, because if we ignored the decimal points, 701 would be between 700 and 710. But we need to write this as a fraction, so we need to change this decimal here into a fraction. To do that, we need to remember that we have 3 digits after the decimal point, and the third digit always tells us how many thousandths we have. So if we have a decimal with 3 decimal places, we can write the number with a denominator of 1000. So we could have 701 over 1000. Now there are lots of possible different answers for this question, but the best approach is to write zeros on the end of your decimals so that you can see a decimal number in between. And then if you know your decimal place value, it's easy to change decimals into fractions, because if we have 1 digit, the denominator is 10, 2 digits, the denominator is 100, but here, because we have 3 digits after the decimal point, the denominator will be 1000.